Hello, we are Group 1. Today, we will furthermore discuss all about heat and temperature.
We are all quite familiar with the concept of heat and can describe the sensation of feeling too hot or too cold. But understanding what things like heat and temperature really are on molecular level can be pretty tricky business.
Nevertheless, we must fundamentally understand them as prerequisite to learning about thermodynamics. So, let's dig into this abstract concept.
We'll start with temperature. Like the temperature outside today. It might be hot, it might be cold, but in science, we want to quantify everything that we can. So saying something is hot or cold isn't just enough.
We want to be able to say how hot or cold with numbers, but that begs the question, what is the temperature is physical measuring?
The temperature is measuring the amount of heat energy available for work in a system, and heat energy is related to the average kinetic energy of the atoms and molecules within that system. We know that greater kinetic energy means objects will move faster, and this is true of molecules in the atmosphere. Just as it is of microscopic objects, so higher temperature simply means faster moving particles.
Kinetic energy of motion is distributed amongst the translational or side-to-side motion, rational or spinning motion, and vibrational motion, where the content bonds in a molecule bend and stretch.
Heat will flow from hot objects to cool objects because as the particles move, they will impart some of their kinetic energy onto their particles through collisions.
This will continue to occur until the whole system is at the same temperature in a state called thermal equilibrium. This is how thermometers measure temperature. Heat from the environment will be in contact with the thermometer and flow into the thermometer fluid, causing the atoms to gain kinetic energy, and the column will expand until it is in thermal equilibrium with the environment.
Thus, allowing us to read the temperature in one of our man-made units. We must bear in mind that all phases of matter expand with higher temperature, whether solid, liquid, or gas. This phenomenon is called thermal expansion.
Energy is transferred as heat in a wide variety of processes. When a collision occurs, there is usually some heat generated. Friction can cause heat as well.
Heat is therefore a kind of energy transit and will be measured in joules just like any other kind of energy.
Furthermore, the transfer of heat energy will always alter the temperature of an object, as heat will always flow from the higher temperature object to the lower temperature object until thermal equilibrium is reached.
Relate this to our daily life. This explains why a cup of coffee, which is hotter than your hand, will transfer heat into your hand, while a cold piece of ice, which is colder than your hand, will cause heat to be transferred out of your hand and into the ice.
These events produce the hot and cold sensations we feel in our day-to-day life. Thank you.